Hi everyone, bonjour. The IB Crocodile is here. Welcome to my channel. Today I would like to discuss how to integrate secant of x and how to integrate secant to the power of 3 of x. This is important. I mean, this is like required if you are taking IB MAA analysis and approaches higher level. You need to know how to do that. Okay, so let me step back a little bit and let's talk about, what is the integration? So the integration, is the anti-derivative or the opposite operation of derivative, right? Like, for example, and of course, you need to be very good. You need to be master in the differentiation before you go to integration. So make sure when you start your differential calculus, make sure you are very good in differentiation rules, and then that will help you very much in integration as well. Okay, so let's say, we have a function y is equal to 10x. Okay, so y equal 10x. If I ask, okay, if I would like to find the dy by dx, what is dy by dx of tangent, right? So dy by dx is basically secant squared of x. So you can differentiate 10. It is on your data booklet also. You don't have to memorize this, but I mean, it's nice to remember. But I mean, it is in your data booklet. So the derivative of tangent of x is basically secant squared of x. So now, if I would like to say, okay, what is the anti-derivative or what is the integration of secant squared of x dx? Now I can do that because the anti-derivative of secant squared is basically, I'm going back to 10x, right? So the integration of secant squared x is going to be 10x, easy, because it is just very clear. I have one function derivative, so the anti-derivative would, bring me back to the original function. Okay. Now the challenge now, if if we need to find the integration of 10x, that is really, starting now to have some challenges, because I know how to differentiate 10x, but how to integrate 10x? If you think like, okay, what is the function, whose derivative 10? There is none. There's no function whose derivative is 10x. So what to do? So in this kind of cases, we need to apply some algebraic manipulation to maybe rewrite the function in a certain way, or multiply by certain function. So I will show, and then use the rules of the integration, right? So for example, here, integration of 10x, I can rewrite that as the integration of, okay, sine x over cosine x. So I can rewrite 10 as sine over cosine. Okay. And here I'm going actually to use inspection. Integration by inspection is very powerful. So what do I mean by that? When you look at a fraction, or rational expression inside the integration, the first question you ask yourself, is the numerator the derivative of the denominator? Again, if the numerator is the derivative or close to the derivative of the denominator, so the integration will be ln the denominator. Let me prove that to you. So we all know that the integration of 1 over x, what is the integration of 1 over x dx? This is in the booklet, right? I mean, this is very, very common. Okay, you would say just ln the absolute value of x plus c, right? But the reason, or the main reason that you could say that, because actually the derivative of x, which is 1, is up there. So the inspection, again, if the derivative of the denominator is up in the numerator, the integration is going to be ln the denominator, and that's it. And you don't need substitution here. I mean, really, if you understand the inspection, in many cases you don't need substitution. But of course, some people feel more comfortable with substitution. I can show it as well, but let me focus today on inspection. It is very powerful method or approach for integration. So now let's now think, okay, what is the derivative? What is the d by dx of cosine x? What is the derivative of cosine x? Okay, is basically negative sine x, right? Derivative of cosine is negative sine. So I have here sine up. Oh, I'm very close. So what I need here? I need just this negative here, right? So what you can do, you can multiply by a negative and divide by a negative one. So now in this case, you can see, oh, now I have the derivative of the denominator at the numerator. So right away in one step, this is going to be negative ln the absolute value of cosine x plus c without the need of substitution at all. So let us continue. So my main target today is to find the integration of secant x. Okay, secant again. Let's now step back a little bit. So we know how to differentiate the secant of x, right? Like derivative of secant. Okay, so let's say, okay, I want to, okay, let me just maybe use different color to be very clear. Okay, so let's say I want to find the derivative of secant. Okay, so let's say y is equal to secant of x. So dy by dx, which is the first derivative, is going to be secant x times 10x, right? So you can differentiate secant, no problem. You have it in your booklet. It is common rule. Nice, very easy. And again, in the same time, you know, if you have the integration, which is the antiderivative of secant x tan x dx, what would you say? Oh, what is the function? You know, whose derivative? Secant times tan. Oh, that is sick. So this is integration again is very easy, very straightforward. You know, that would be secant of x. Of course, we have to add the constant of integration because this is indefinite integral. Okay, so you get the point. So you have derivative, antiderivative. So you can differentiate sec. Yes, I can differentiate secant. But now I have the challenge now. How can I integrate secant of x? Right? So this is really my main target today, but I had to you know to provide this introduction. So anyway, so secant of x, okay, what is the manipulation? Okay, you need to know this. So secant of x, what you're gonna do, you multiply both. So let's say this is over 1. Okay, so let's multiply both numerator and denominator by secant x plus tan x. So this is the manipulation that I'm going to use, and then using the rules of integration. So secant plus tan, you multiply both numerator and so what you get. So that will be the integration of, let's say I'm going now to expand the brackets. So secant squared of x plus secant x tan x. Okay, I just expand, you know, I just multiply secant over these two terms here. Okay, and then we have here at the denominator sec x plus tan x, right? Because whatever you do at the numerator, you have to do it at the denominator and dx. Now again, inspection. So ask yourself one question: what is the derivative of the denominator? The derivative of the denominator, let's see. Okay, so what is d by dx derivative? Okay, derivative of secant x plus tan x. Let's see. Derivative of secant, we know it. Derivative of secant is sec tan. Nice. So derivative of secant is sec x tan x. And then plus derivative of tan x is secant squared x. Nice. Now compare this with the denominator. Do you have this on the denominator? Yes. So this is in one step by inspection. Is going to be len, the absolute value of sec x plus 10x. And then don't forget to add the constant of integration. Okay. Now, this is not done yet. Let's have a look at one more challenge. Okay, so now we know how to integrate secant of x by using this manipulation, multiplying up and down. Now we have the integration of secant cube of x. So let me rewrite this as the integration of secant squared x times sec x. Okay, just adding the power multiplication dx. And then you have now two functions multiplied by each other inside the integration, inside the integral. So that means what? That means, by parts. You use by parts. Okay, not 100% all the time like that, but I mean, okay, 80% by parts. But then sometimes I can use substitution. I can use even inspection, but that will come with experience. But here, okay, let's just do by parts. Okay, and then by parts, the rule is going to be, the rule by parts, the integration is going to be uv minus the integration of v du. So what is the idea of by parts? You take one of them, you call it u, and that u has to be derivative, like differentiable, and then another one, you call it dv, and that dv has to be like you can integrate. Okay, so when you look at sec squared x times sec x, okay, can you integrate sec squared x like easily? Yes, because sec squared x is the derivative of 10, right? So what I would do here, I would say, okay, I would take dv as sec squared x, so then v will be the integration. Okay, so v is going to be the integration of sec squared x, which is tangent of x. And then I will take u as sec x, which is the second one, like the product. Okay, so if you have u is sec x, can you differentiate easily sec? Yes, of course. So du is going to be secant x times 10x. And now let's substitute. And I'm going to call this I. So I'm going to call this I. This is what we need to find. I with the integral equal sec cube of x. So I, now I'm going to apply the by parts, integration by parts. So u is basically sec x, uv, so v is 10x, right, minus the integration of video. I mean, I call it video just to remember. So v is 10x, okay, and then du is going to be sec x times 10x. And of course, you need to add dx here. I mean, I should add dx there. Okay, so then, okay, let's see what we end up with. Okay, 10 times 10 is 10 squared. So you have the integration of sec x times 10 squared x dx, right? So then you may see, okay, maybe you can continue by parts again. So I'm going to, because again, I have sec times 10 squared, which is two functions. They have no relation. I mean, or maybe we can, okay, or maybe you can use one of the identities. Let me try using one of the identities. Okay. So we know for sure that sine squared x plus cosine squared x equal 1. So if you divide by both sides by cosine squared x, what you get? If you divide both sides by cosine squared x, what you get? Sine over cosine, that is tan squared x, right? plus 1 equal 1 over cosine. The reciprocal of cosine is secant. So I have secant squared x. So that implies that tan squared x can be secant squared x minus 1. So let me try that. Let me try that. So now we have I is going to be sec x tan x and then minus the integration of sec x, but then I'm going to replace tan squared by sec squared minus 1, using the Pythagorean identity. Okay, so now this part here becomes, okay, let's expand. So it becomes sec cube of x, right, minus sec x. Even you can split over over addition and subtraction. That's fine. So let me say, okay, so this is negative sec cube x dx minus the integration of sec x times 1, which is sec x dx, right? Now we have minus outside here, so this become positive if you like, right? Because we have minus here in front of this whole thing, right? So if you expand, make sure you have this negative with you. So the negative times negative is positive. And then I still have here sec x tan x. So now what you see now, oh, we have the original integral again in front of us. What we call it? I. So this is I. Now you have negative I. It can move on. Move to the other side with positive sign. So you would have I plus I is going to be, I just shifted to the other side, is going to be sec x tan x plus the integration of sec x dx, which we just did it in the previous slide. Integration of sec x is len sec plus tan. Of course, you need to show it. Of course, I would not show it again, but yeah, if you face like an IB high level paper 1, let's say, okay, integrate sec cube x or something around that. So you need to show all these steps here. Okay, so but I will not show it. We know for sure now. We know, I just proved it for you, that the integration of sec x is len sec plus tan, right? So now the final answer, we have 2i is going to be sec x times tan x plus ln the absolute value of sec x plus tan x, right, plus c. But then I need I only, so that's easy. You can just divide all of this by 2. Okay, so that will be the integration of sec to the secant x of to the power of 3. So I at the end of the day is going to be 1/2 multiplied by all of this, plus c. Okay, c over 2 is just c. That's fine. Okay, so I hope that was helpful. Please feel free to leave any comments, likes. If you consider subscribing to this channel, that would be great. If you feel like it is helpful to you, specialized in IB and of course in mathematics integration and other topics as well. Okay, so thanks for watching and have a good day.